Welcome to qnawire.
Data from the U.S. Federal Reserve Board in 2002 on the percentage of disposable personal income required to meet consumer loan payments and mortgage payments for selected years are found in the data. We first want to compute the mean and standard deviation of the two variables in the data set. Describe each variable using these sample characteristics. All right, so I've already put this into the decimals graphing calculator. If you add a table and input the data, you can see the data. You can calculate the mean and standard deviation pretty quickly from something like decimals. So we can say the mean for the x's, which are called x1, is 7.23. So I'll call it the mean of consumer debt was 7.23. The mean household debt would be the mean of y1, which is 5.91. The standard deviation of consumer debt and household debt standard deviation of consumer debt was 0.67 and of household debt 0.16 to the nearest hundredth. What is the value of the correlation coefficient? You can find that from decimals doing y1 is approximately ax1 plus b, and that's 0.53. Construct a scatter plot. So we can see the scatter plot here. Based on these, is it reasonable to conclude in this case that there's a strong relationship between the variables, linear or otherwise? I wouldn't say strong because it is spread out quite a bit. There could be a better quadratic one, which you could test also here. So we could test y1 is approximately ax1 squared plus bx1 plus c. And it's better, that's for sure. But I don't know that I would still categorize it strong. So I'm going to say see the graph, and then for part 4, I wouldn't call it a strong relationship. There is one, but not necessarily strong. And does seem like there could be some curvature. So I'm going to say maybe quadratic better.